Now we're going to look at some other vertical transformations. Specifically, we're going to look at vertical stretching, vertical compression, and vertical reflection of graphs. So first we're going to look at how multiplying the outputs of a function by a positive constant can warp the graph vertically. Similar shape, but not quite the same. We're going to look at what happens when we change the sign of the outputs of a function to reflect the graph over the x-axis. And then we're going to look at an example. So remember the function y equals f of x from the last video. This is the one that we were working on before. Got a few points on here, a few extra points, a few different points. Question is, what happens when we multiply each y coordinate by 2? So that first y coordinate becomes an 8. The second one becomes, about 3.8, and the third one negative 3.8, and the fourth one negative 8. So in other words, we're taking our old y, which was f of x, and we're multiplying it by 2 to get y equals 2 times f of x. So on the left we have our old graph, on the right we have our new graph. A couple of observations. First of all, note that points that are far away from the x-axis on the original graph get much farther away when you multiply them by 2. So for instance, that first point, negative 4, 4 becomes negative 4, 8, and increases by 4. And again, that's both above and below the x-axis. When we had x equals 4, y equals negative 4, that doubled to negative 8. So that got twice as far away from the x-axis. And the points close to the x-axis, the remaining two, get a little farther away. Right? So the 1.938 became 3.875, which is a little farther. It was still farther away from the x-axis, but not nearly as much as going from 4 to 8. And again, that happened both above and below the x-axis. So what this says is that it takes the original graph and it stretches it vertically. All right, so back to our y equals f of x again. What happens when we multiply each y coordinate by another number, say 1/2 instead of 2? Well, our old y coordinate was f of x, and we're just taking that and multiplying it by 1/2 to get 1/2 f of x. And here's what the graph looks like. On the left is our original function. On the right, when we multiply each y coordinate by 1/2. Notice this time points far away from the x-axis get much closer, right? So the negative 4, 4, and the 4, negative 4 get closer by 2. And again, that's both above and below the x-axis. And the points close to the x-axis get a little closer. The 1.938 became 0.969, and the negative 1.938 became negative 0.969. So again, they got closer, but not nearly as much closer as the ones that were farther away from the x-axis. And again, that happened both points above and points below the x-axis. And so what we're seeing here is that the original graph, both graphs are similar, except the second one takes the original graph and it vertically compresses it. So in general, if we're going from y equals f of x to y equals some constant c times f of x, what we're going to get is either some vertical stretching or some vertical compression, depending on the value of c. If we remember from when it was 2 times f of x, we got vertical stretching, and that is in fact going to be true for all values of c that are greater than 1, 3 times f of x, 5 times f of x, even 1.5 times f of x. And that gives us vertical stretching. Now, when our c is between 0 and 1, like it was with 1/2, that's going to give us a vertical compression. All right, so let's see what happens when we take our old y coordinate, f of x, and multiply it by a negative number. So this one, we're just going to change the sign. We're just going to call it negative f of x. If you want to look at the graph, again, they look very similar. They look kind of like a mirror image of one another. The points above the x-axis get flipped down below the x-axis, right? Because the y coordinates are changing their sign. And again, it's by the same distance that they originally were. The points below the x-axis go above the x-axis, and again by the same distance because we're just changing the sign of the y coordinates. And so that means when we have y equals negative f of x, it has the same graph except reflected over the x-axis. All right, so now you can try some vertical stretching, compression, and reflection on the PDF file included with this video.